Hi Amrita, have a look at this question. Okay, so here
Sure.
it says d square y by dx square is 5 cos 2x, and gradient is given of the original function at that particular point minus pi by 12 comma 5 pi by 4 is 3 by 4. Is that clear, Amrita? Now question is,
Yes.
can you figure out the original function? Obviously, I know that you do know how to handle this, Amrita. What's the first thing that you're going to do? In order
Since we are
tell me,
the
Amrita.
equation of this curve, we are going to integrate
When you integrate
y.
left side, what do we get, Amrita?
When we integrate, we'll get a constant
No,
function
when you integrate the left side, Amrita, you will
dy
get
by dx.
dy by dx. Now, the right side, you will get integral of 5 cos 2x and a constant. That's correct. Let me write this one down, Amrita. What you're trying to say is, come in, dy by dx will give you this. Is that correct, Amrita?
Yes.
Okay. Now, when you integrate cos 2x, you will get sine 2x. Now, you need to anticipate that 2 being a factor after differentiation. So, you say 5 by 2 sine cos 2x. Let's see. Now, the next thing that we need to figure out is, Amrita, what is the value of the constant? Okay, Amrita. So next thing what we need to do is we need to figure out the value of the constant, Amrita. Now, look at the question. Gradient is given. Gradient is same as the first derivative, correct?
Yeah.
Now you need to apply that onto that particular point of x. What is that x value? Minus pi by 12, correct? And that should give you 3 by 4. Is that clear, Amrita?
Yes.
Okay, so let's do that one. So this is what the question says. Now, instead of the left side, we could very well substitute what we have already in the previous step, 5 by 2 sine 2x. Instead of 2x, you could actually substitute that value. What is the value, Amrita?
Minus pi by 12.
Exactly. So
Yeah.
let us substitute that, and this is what you will get. Is that clear, Amrita?
Yes.
Now, why are we doing this? Well, we are doing it so that we can figure out value of c. Okay, so what we need to do is we will try to isolate term by term so that c will be isolated in one side. So let's say consider this step done first. And what we need to do is we need to, okay, 4 multiplied across, you will get this. Now we isolate c alone onto one side, everything else to the other side, Amrita. Let me write that one down. So now we have got c. You don't need to use your calculator. By now we know that sine pi by 6 is minus half. Correct, Amrita? Let us substitute all of those values and simplify this. So c is the whole thing. Wherever we can substitute the values, we do it, and it is 2. Now,
Right.
after having found this, let's go back to the original equation, 5 by 2, that whole thing, right, on the top of this page. Let's substitute this value 2. And so this is what we have reached. Is this clear, Amrita?
Yeah.
Now, question is, what is y? So what's the next thing that you're going to do? Obviously, you need to integrate this. When you integrate it, what do we get on the left side, Amrita?
Y.
You will get y. What do we get on the right side?
So 5 by 4 minus.
Yeah, you just need to integrate the right side. Let's keep it as this for now, and let's do one step at a time, Amrita. So when we integrate sine 2x, it will become minus cos 2x. Again, we need to anticipate that 2 coming in and divide by 2. Is that okay, Amrita? Well, there is slightly more systematic way of doing it by substituting u is equal to sine 2x. Instead of this sine 2x, you could very well substitute it as u. But at this stage, it's very trivial for us, so I'm skipping that. Is that okay, Amrita? Let's continue now. So now we need to calculate value of d, and it doesn't take much time. If you look at the original equation, Amrita, question says the original function goes through these 2 points. This one point with these coordinates. Correct,
Right.
Amrita? So that means this is the x value, corresponding y value is this. So we could actually
Right.
substitute that into the next one, Amrita. Both x and y value,
Right.
we take it from that point. So wherever, okay, let's go back to this one again. 5 pi by 4 will be y, x will be minus pi by 12. Substitute that, Amrita, and then we will get this. Instead of y, you have this. Instead of x, wherever x is, we substitute this. Is it clear? Now we need to simplify this, Amrita. What is cos? We could actually further simplify it. It is cos minus pi by 6. What is cos minus pi by 6, Amrita?
Root 3 by 2.
Root 3 by 2. Good memory you have, Amrita. So let's substitute that value, and that will give you much more simpler form. So d will be, let's isolate d onto one side, everything else to the other side. Right? Now let's further simplify, Amrita. So the constant that you see for d will be, let's simplify this. Pi by 6 and 5 pi by 4, we can take it together and simplify. The other two terms we can multiply it and simplify. So you will get 17 pi by 12 plus 5 root 3 by 8. Is that okay? Now finally, it's not done yet. Question is, what is the original function? So instead of c, we put that value we have already done. Instead of d, we substitute this new value. Now, at this stage, you may use your calculator and simplify, but there is nothing in the question that says you need to simplify this. So I'm going to leave my d as it is, and the c is here, and this is the answer to the question. Is it clear, Amrita?
It's very much clear. Thanks a lot.
So much. Okay.